So you see my presenter mode screen, I suspect.
Yes.
Yeah, we see the next slide, no notes. Yeah.
Okay. All right. So let's move forward then. So I was, as I was saying, the Bible plainly reveals that we're in a spiritual war. 2 Corinthians 10:4-5 says, "For the weapons of our warfare are not of the flesh, but mighty through God for the casting down of strongholds, casting down speculations and every lofty thing raised up against the knowledge of God, taking every thought captive to the obedience of Christ." And so what I want to do tonight, is focus on one of these strongholds. They're all serious strongholds. I'm going to focus on the one of uniformitarian geology. Now, let me just clarify that these strongholds are not physical, of course, but are deceptions in the mind. And I would say most people around us, most people in our country have been deeply deceived by all of these strongholds. These are strongholds in the minds of the majority of people around us. So as Christians, if we're to be effective witnesses, we need to understand the nature of this spiritual warfare. I might comment that verse is basically in contrast to the passage in Ephesians 6. This one appears to be primarily offensive. So it means it has to do with pulling down of these fortresses or strongholds. So anyway, I'm going to be dealing with the stronghold of uniformitarian geology. Now, of course, we all are familiar with what the Bible says about the flood and the cause of the flood, that God saw the wickedness of man was great on the earth. Every thought, every intent of the thoughts of his heart was only evil continually. God, he reveals his decision to blot out man, as well as the animals, the birds. But we see that Noah found grace or favor in God's sight, and God reveals to Noah about building an ark. And so as the narrative proceeds, in chapter 7, verse 19, it says, "The water prevailed more and more upon the earth, so that all the high mountains everywhere under the heavens were covered." Verse 21, "All flesh that moved on the earth perished, birds, cattle, beasts, every swarming thing that swarms on the earth, and all mankind." And re-emphasized it in verse 23, "Blotted out every living thing that was on the face of the land." Only Noah was left together with those that were with him in the ark, and the water prevailed on the earth 150 days. If such a total destruction of land-dwelling, air-breathing life on earth had truly occurred as described in Genesis 7 and 8, what sort of physical evidence should such a cataclysm have left behind? Well, as Ken Ham says so in such a clear way, how about billions of dead things buried in rock layers laid down by water all over the earth? That's certainly what we should expect with a cataclysm as described in those 2 chapters of Genesis. And that is actually what we do see in the record. Yet in today's culture, a wide swath of people regard Noah's flood as nothing more than a quaint myth. Nonetheless, the Earth's fossil-bearing sediment record screams out otherwise. Indeed, these layers testify clearly to global cataclysm beyond what the human mind can imagine. However, until about 230 years ago, most people in the Western world, even well-educated people, took for granted the Bible's testimony of a global world-destroying flood as historical reality. So what caused the change between then and now? Well, the short answer was there was deep deception and came primarily through the intellectual movement in the 1700s known as the Enlightenment. And let's look at some of the players involved, especially relating to geological matters. One was James Hutton. He's regarded as the founder of modern geology. Why is that? Because he introduced two key ideas, the ideas of uniformitarianism and deep time in his book, Theory of the Earth, published in 1795, on which modern geology is built. His famous quote regarding Earth history: "No vestige of a beginning, no prospect of an end," because he understood in his mind present day processes operating at approximately present day rates were responsible for the geological record, and he envisioned these processes operating over vast spans of time, so that there was no, looking back, there's no vestige of a beginning. And if there's no agent or agency to alter these laws that are responsible for these processes, he saw no prospect of an end. Okay, so that was a pretty radical idea in his day, but that deception took hold. And born the year that Hutton died was Charles Lyell, so he was in the next generation. He's considered the father of modern geology. He's famous for his book, Principles of Geology, which was first published in 1830, but then updated in 11 subsequent editions. Most geologists in the 19th century had that book as their main textbook, geology textbook. Lyell was zealous in his advocacy of uniformitarianism, summarized in the slogan, "The present is the key to the past." So that sort of laid the foundation for Charles Darwin. The concepts advanced by Lyell in his book were foundational to Darwin's speculation on how life might possibly have arisen with no action on God's part. Darwin took a copy of Lyell's book on his voyage on the Beagle, 5-year voyage around the world. And then when he got back, he became good friends with Lyell. So I say that Darwinian evolution is merely a logical extension of the uniformitarianism of geology to the realm of biology. So that's sort of how those are some of the key events that got us into got this idea of deep time and uniformitarianism, introduced it into the Western world. But that event was prophesied 1800 years earlier by the Apostle Peter. 2 Peter 3, Peter wrote, "Know this first of all, that in the last days mockers will come with their mocking, following after their own lusts and saying, where is the promise of his coming, Christ's coming? For ever since the fathers fell asleep, all continues just as it was from the beginning of creation." So that is their reason for doubting any kind of supernatural intervention from heaven. They say all continues just as it was from the beginning of creation. Peter's prophesying that. He goes on to say, to refute it, for they are willfully ignorant of this fact that by the word of God the heavens existed long ago, and the earth was formed out of water and by water, through which water the world at that time was destroyed, being flooded with water. So here Peter's predicting that scoffers who reject the very concept of God even also will reject the claim that Jesus will return with the excuse that all continues just as it was from the beginning of creation. In effect, they will be saying, because there have been no interventions by God in the past, what reason is there to expect any in the future? Peter counters this logic by pointing out two major interventions by God in the past, namely his creation of the heavens and the earth, and later destruction by means of the flood of a world filled with violence and evil. Peter points out that these scoffers will willfully ignore these two major events in the actual history of the world. Now, the view that all continues just as it was from the beginning of creation is known today as uniformitarianism. It is the proposition that the world's physical history can be correctly reconstructed by extending presently observed physical processes operating at approximately presently observed rates into the indefinite past. The widespread acceptance of this deception, this false version of the physical history of the world, rapidly decimated biblical Christianity in Europe and is in the process of doing the same here in the United States. So as we look at the rocks of the earth, what is the message that these rocks are proclaiming? Well, the Grand Canyon provides a representative glimpse of the sediment layers beneath our feet across most of the continental regions of the earth. Among the things that these layers reveal, what we've already seen, is the reality of billions of dead things buried in rock layers laid down by water all over the earth. And so we have these fossil-bearing sediment layers that appear abruptly, all these layers. The first fossil-bearing layers appear abruptly just above a global scale discontinuity known as the Great Unconformity. These layers consist of sediment particles transported and deposited by moving water on a massive scale. They commonly continue horizontally for hundreds to thousands of miles in both directions. This implies that the water processes responsible were enormous in their horizontal scale. Moreover, this sequence commonly displays flat boundaries between layers with little or no erosional channeling across the layer boundaries. And this is illustrated vividly by the boundary between the Coconina Sandstone and the Hermit Shale, readily observable in the Grand Canyon, shown in this next slide. This not knife-edge sharp boundary visible is shown here is visible on the Bright Angel Trail just below the Visitor Center on the south rim of the Grand Canyon. Just a complete change in the particles and the sandstone to shale, sharp change in color. So it's just abrupt change, no evidence of any erosion on that boundary, just a sudden. So it basically signals a change in the source sediment, the sediment source, and just an abrupt change in the rapid deposition that was taking place. The implications of these observational realities are profound. To deposit such uniform, horizontally extensive layers with flat boundaries between them requires that vast portions of the continental surface were flooded by rapidly moving water, and these surfaces were nearly smooth. The water speed had to be high to keep sediment particles in suspension over such great distances. These observations imply a regime of erosion, transport, and deposition in the past radically different from today. In today's world, the higher portions of the continental surface are deeply sculpted by erosional channels. Sedimentation in river deltas is restricted in lateral extent. In most settings, layering is entirely destroyed by burrowing organisms. So we're not, for the most part, seeing, except when there's a storm surge, we rarely see any layering left behind. And today's continental surface is dissected in many places by spectacular erosional channeling. And here in this slide, we've seen the The Bryce Canyon, Zion Canyon, and Grand Canyon are vivid examples of the kind of erosional channeling that dominates the Earth's surface today. So as far as that dictum of the present being the key to the past, it simply doesn't square with what the record shows. And in addition, this rock record shows that there's abundant physical evidence that water velocities were extreme. In several cases, water velocities were sufficient to produce underwater sand dunes 50 to 100 feet in height. And this is very prominent in the Navajo sandstone, where it has these huge cross beds that can be 50 to 100 feet high, a certain indicate of high-speed water flow. Here's a photo of some of the cross bedding in the Navajo sandstone, and the finer structure corresponds to layers deposited on the front side of huge underwater sand dunes produced by the high-speed water flow. So are processes responsible for these features we've just looked at prevalent today? The answer is obviously no. So the central premise of Lyell's book, that the present is the key to the past, is therefore easily falsified today. Evidences we've just examined show how the geology community veered into the weeds 190 years ago and has been lost there ever since. That's a pretty harsh indictment of the geological community today, but I believe it's valid. They simply are blind. They simply turned a blind eye to this evidence that falsifies that dictum that has been followed ever since Charles Lyell. So, and the only place within the biblical account of world history that formation of such laterally extensive fossil-bearing sediment layers possibly could have occurred, of course, is during the Genesis flood. Now, as far as the intensity, the Genesis text reveals that this cataclysm unfolded within the time span of only a single year. So all of these layers had to have been deposited within that short span of time. And so given the biblical time scale and the striking physical evidence for a global flood cataclysm, some obvious issues come to mind. First, at a very basic level, how could so much physical geological change occur in such a brief interval? And then what could have been the primary causal mechanism? Well, some major answers to these two questions have come from the ocean bottom over the past 70 years. A huge discovery was made in the 1960s with the sonar technology developed during World War II. The ocean floors was imaged in great detail by 1960, and it was discovered that all of today's basaltic ocean crust has been formed very recently in Earth history. All of it is younger than most of the continental fossil-bearing sediment record. This blue arrow marks, and that actually corresponds to the limestone layer at the rim of the Grand Canyon. All of the igneous ocean floor on Earth today has formed since that layer was deposited on the continents, the base of the blue arrow. This means that all of today's ocean crust has formed since the onset of the Genesis flood. So this implies that the opening of the entire Atlantic Ocean occurred during the flood, and also that continents migrated by thousands of miles in only a few months' time during the flood. Now, I might just mention that I came to realize this in the spring of 1978. And I realized that this was huge as far as understanding the flood is concerned. And at that point in the creation literature, I could find no mention of this reality in the literature. And one thing led to another. That was basically what prompted me to leave Campus Crusade and enroll in a Ph.D. program at UCLA to work on these issues at a professional level, to be able to get the credentials and the training to do that. But to me, the case was very almost, could be no uncertainty about that conclusion. And so that perspective that all the ocean floor today formed during the Genesis flood basically is the background for this understanding that has come to be known as catastrophic plate tectonics. So it is merely the observations from the ocean floor that leads to that conclusion. Because of some of my work in the computer modeling, some people think it's the computer modeling. No, it's these physical observations of the character of the ocean floor that's the basis of catastrophic plate tectonics, combined with the biblical account of the flood. Such large-scale tectonic change at the Earth's surface requires that the Earth's interior also have been involved in a profound way. So let's consider some of the basic aspects of the Earth's internal structure. This is a cross-section through the Earth. It shows these two main parts of the Earth: the mantle, which is mostly solid silicate rock, and the core, which is mostly molten iron. The uppermost part of the mantle is the thin, cold, mechanically strong lithosphere, shown at the very top. The plates basically comprise the lithosphere. So the lithosphere is broken into about a dozen large plates. Below the lithosphere is the much weaker asthenosphere, shown there, and its weakness allows the plates to move freely over the region, over the mantle beneath. That lithosphere is some 1,000 times weaker than the lithosphere. So it allows the plates to slide almost without any tractions on the bottom, almost freely over the rest of the mantle. Okay. And so with this understanding, in catastrophic plate tectonics, the ocean plates can slide into the mantle and sink because they are cooler and denser than the mantle rock beneath. And the energy for driving this process is simply the gravitational potential energy of that cold lithosphere. Plus, as I'll mention later, that the built-in tendency, the inherent tendency of mantle rock to weaken under stress. Okay, so this is a little close-up of what happens when an ocean plate plunges into the Earth's interior. This happens at a trench, a deep ocean trench, and often adjacent to a block of continental lithosphere that has a low density, a layer of granitic crust on top. So where these ocean plates are plunging in the Earth, the overriding plate typically is locked against the subducting plate and only episodically unlocks when the stress reaches a limit. And that unlocking, sudden unlocking and slipping is what causes earthquakes, and in many cases, tsunamis. I hope tonight to get a little more to that. This is a close-up of what happens at a spreading ridge where two plates are pulling apart. And there's hot melted magma. This is one of the few places in the Earth where the mantle is partially molten, produces magma That magma rises up to fill the gap where two plates are pulling apart. So that magma rises and freezes it to fill that gap. So the catastrophic plate tectonics is similar, it turns out, to conventional plate tectonics, except for the fact that the plate velocities are about 1 billion times higher, about 5 miles per hour instead of about 2 inches per year. So how is that, physically, how is that possible? Well, laboratory experiments show that mountain rock weakens dramatically under stress at stress levels that can exist inside the earth. And this weakening is what provides the potential for a runaway catastrophe. So before we get into that issue anymore, let's consider how much continental motion occurred during the flood. I've already given a pretty good hint as to the answer, but the following sequence of images summarize how the continents have moved just since the time when the supercontinent Pangaea existed in the middle of the flood, as reconstructed by secular Earth science community. These images were produced by Professor Ron Blakey of Northern Arizona University. So I'm just going to run through them quickly. This is Pangaea in the early Triassic. And as you go forward in time, you see the breakup of Pangaea, the movement of the continents to their present locations. I'm going to move it backwards there and then forwards again. So we see just incredible amount of motion of the plates, and all of that motion, continental motion, had to have unfolded during the year of the flood. Actually, during the last half of the flood, actually. That sequence is within the span of time of fossil-bearing sediments on the continents. Because fossils are indicative of the portion of the geological record associated with the flood, all that plate motion must logically have accompanied the flood and unfolded in the span of a few months' time. So catastrophic plate tectonics, like conventional tectonics, accounts for features like the mid-ocean ridges, the deep ocean trenches, volcanism adjacent to the trenches, and the global distribution of earthquakes. However, there are some geological processes distinctive to catastrophic plate tectonics, such as supersonic steam jets emerging from the seafloor along 40,000 miles of rapidly spreading mid-ocean rift zones. So this is a little bit of an artist rendering of what those steam jets would have looked like. That came ripping up through the layer of ocean water and training a lot of that liquid water as these jets penetrated into the stratosphere, carrying that liquid water up above, which then fell back as torrential rain. A crucial physics issue, again, however, is how can these plates sink vertically through 1,800 miles of mountain rock in a few weeks' time? So again, we're talking about this top layer, this rigid layer, cold layer at the top called the lithosphere, which is broken into the plates. How's that able to peel away, sink into the mantle at speeds of meters per second or several miles per hour? How can they do that? Well, the main answer is that mountain rock weakens under stress, and that leads to the potential for a runaway catastrophe. So the deformation properties of mantle minerals have been measured in laboratories all over the world since the 1960s. And this is an apparatus from about that era in Paris, where the cylinder is an oven that controls the temperature of the sample very carefully. The rods, silica rods in the top and bottom, apply a force on the sample at the center, and so what happens that for a given period of time at a given temperature, that sample is deformed, and then afterward it can be studied under an electron microscope. And generally what is seen, you can see that these layers of atoms have slid past one another like if you shear a deck of playing cards, what the edge of that deck looks like. And so these processes have been carefully studied. Sometimes you get deformation in two directions. And so these processes have long been carefully studied. Enough data is available to draw these deformation maps as shown here. I don't want to try to explain it other than the regime that can be measured in the laboratory is where these two red lines cross. And that's precisely the region that you need to be in for catastrophic plate tectonics. So that region has been well characterized in laboratory studies for decades, and corresponds to strain rates, for anybody who understands what that is, on the order of 10 to the minus 4, 10 to the minus 5 per second, which those rates are readily can easily be achieved in the lab. But the rates that are supposed to occur inside the Earth of like 10 to the minus 14 to the minus 17, that would take hopelessly long, centuries or millennia to run those experiments. So we don't have actual, good physical experiments in that range, but we do in the range of where this power law creep operates. Okay, so what I've done is I can take those experimental data, those deformation properties, and put them into a computer program and use that to describe how the rock deforms. And what that relatively simple calculation shows, it shows runaway catastrophe. So here I'm going to show I have some snapshots from a little animation. This is the starting, right near the starting point. This blue blob at the top represents coal rock, which has come down from the surface and settled along the core of the boundary between the upper and lower mantle, which because of the phase change tends to oppose flow through that boundary. So even today, there are slabs that have settled on that boundary, have not penetrated. I'm suggesting that before the flood, there were some areas where that was the case. And when I put that in this model and just let it run, that runs away and is able to penetrate to the bottom very quickly. So these are some snapshots from the video. That's at 30 days. And this is what that video looks like. And what it shows is that the physics works. That weakening effect of the mantle minerals is sufficient to lead to this catastrophic behavior, essentially a mantle overturn in just a few weeks' time. So the simulation, though it is only 2D, demonstrates that the physics indeed works. Specifically, that stress weakening in rocks can produce catastrophic consequences in a planet with the gravity field of the Earth, with the mass of the Earth and the subsequent gravity field that the Earth has. So now I want to show a 3D calculation using the Terracote, which I developed as part of my Ph.D. research at UCLA. And here's a cutaway grid of the view of the grid. This one is, by today's standards, relatively coarse. It's got 1.3 million cells, and I can run it fairly easily on my laptop today. Solves the equations of conservation of mass, energy, and a force balance in each cell on each time step. So it basically solves what are known as the Navier-Stokes equations. And this is a view of, this picture shows reconstruction of Pangaea. I'm going to use that as initial condition for this calculation. This is my version, my rendition of the distribution of continent at that point in the Earth history, at that point during the flood. The dark lines outline the present day continents in that configuration. And to get the calculation to go, I put in some temperature anomalies along the boundaries of that supercontinent that extend down 400 kilometers down into the mantle and are 400 degrees colder than the surrounding rock at each depth. So it's a relatively minor kind of perturbation to get the calculation running. So starting from that initial condition and just turning it loose, this is the solution I get. It pulls that supercontinent apart, and the plates move basically in the right direction. So I'll run that again. So that's how those blocks move. This is a slice through the equator showing that downwelling cold material plunging down to the core mantle boundary and hot material rising up to fill the gaps at the surface. Here's a view from the North Pole, that same calculation showing the migration of North America to the west and overriding what is known as the Farallon Plate and producing the Western Interior Seaway, it turns out. Anyway, I don't have time to go into details on that. Here's the view from the South Pole. Even though this is fairly crude, it does show that the mechanics works and that subduction around the Pangaea would have pulled it apart and the blocks would have moved very close to what we observe the seafloor data today to tell us how they have moved. So is there evidence supporting a recent episode of catastrophic plate tectonics? Well, the answer is yes. Seismic images of the mantle reveal a ring of unexpectedly cold rock at the bottom of the mantle beneath the subduction zones that surround the Pacific Ocean. And these are two views of the Earth, the inside of the Earth. And these are seismic tomography images based on some tens of thousands of earthquake data. And the blue features represent coal material right at the top of the core. And you can see that same ring from both views, one of the Western hemisphere, the Pacific hemisphere, and the other, the Eastern hemisphere, basically above Africa. In addition, you see these red features, these red blobs. They're hot relative, it appears. It looks like hot rock squeezed up like toothpaste in the middle of these two rings of cold material that have settled down from the surface down to the core mantle boundary. Now the blue temperature, and the blue implies low temperature, the red high temperature, and the inferred temperature difference is about 3,000 degrees centigrade, or something like 5,000 degrees Fahrenheit. So the problem with that is it implies the temperature of the blue ring at the base of the mantle is nearly the same as that of lithospheric rock near the Earth's surface, because we have a pretty good constraint on what the temperature of the core mantle boundary is, and that 3,000 degrees doesn't leave much room. So that rock basically has to be cold, has to be almost as cold as the lithosphere at the Earth's surface. And so the small amount of heating implied in by that blue region is powerful evidence for an episode of runaway subduction in the Earth's very recent past. That rock, that blue volume, just that rock hasn't had time to heat up. However, in the uniformitarian time scale, it's estimated that it takes about 100 million years for that rock to settle down to the bottom. In that time, it would have been warmed up dramatically, more than it shows here. So this is a huge enigma for the Earth science community. They have yet to come up with a solution to that basic problem, but it's basically staring them in the face. And it's obvious that rock must have gotten down there very recently. So basically, this is powerful evidence for a recent episode of catastrophic plate tectonics. So what would have been the energy source? Basically, it's the gravitational potential energy associated with the initial temperature differences. And so doesn't require any kind of additional energy source. Just that gravitational potential energy is sufficient to produce that overturn. All right, some further obvious questions, however, which I have not addressed yet. 1, how were the continents flooded? 2, what caused the waters to drain away? And then by what means was the huge volume of sediment-bearing sediment generated, fossil-bearing sediment generated, transported, and deposited? I'll just be very brief on these answers. First, what caused the flooding of the continents? Answer is rapid replacement of cold, high-density ocean plate with hotter, less dense ocean plate adjacent to the mid-ocean ridges caused the volume of the ocean basins to decrease, the sea level to rise, and water to spill onto the continents. So here in this cutaway view at the top, you see the mid-Atlantic ridge. As new crust formed there, that was hotter and buoyant, and it displaced some of the volume of the ocean basins, causing the sea level to rise. Very simple explanation. So it's the hot lithosphere replacing cold lithosphere that's subducting that causes the global sea level to rise. So we have near the bottom on each side, this is where this hot material is rising. You see there's very, very little blue color there, which corresponds to low temperature. That rock is hot. It displaces the sea bottom upward and causes the sea level to rise. Okay, so what caused the waters to recede? Many lines of evidence indicate that after the 150 days during which the waters prevailed on the earth, God caused the newly generated ocean plate to cool toward its present state. This cooling reduced the volume of the ocean floor rock, causing the sea floor to subside and the global sea level to fall by some 1,500 feet. And we can deduce this reality from the geos, these flat top volcanic islands submerged by that kind of depth of water in the Pacific Ocean. Some 200 to 300 of these flat top mountains. Now, the rapid drop in sea level led to rapid runoff of the water from the continents, and we see spectacular evidence of that rapid runoff. One good example is the erosion you see in Bryce Canyon, Utah. This is evidence. These rocks are very delicate. The rock did not have that much time for cementation to take place, for it to lithosify that well. So these are very, very delicate structures. We see the runoff carved all these delicate structures as it rapidly evacuated this area. Now, the next question, I'll try to be brief, but by what conceivable means was the huge volume of fossil-bearing sediment generated, transported, and deposited? The short answer is that tens of thousands of mega tsunamis did it. These were produced by the locking and unlocking of rapidly subducting lithospheric plates. An entire additional lecture is needed to describe that study. I'll be very brief. This is a map of the sediment distribution around on and around the continents today. These darker colors, most of that sediment is on the continental shelves or around the continent. The average thickness of sediment on the continents today is about 1,800 meters or about 6,000 feet. Again, the thickest accumulations are on the continental shelves, the result of runoff during the final stages of the flood. So a paramount issue is explaining how such a huge volume of fossil-bearing sediment came to blanket the continents in an orderly pattern, in the orderly patterns we observe today. And let's take a quick look at the power of tsunamis in today's world. There was this huge earthquake in 2011 off the east coast of Japan, most powerful earthquake ever recorded in Japan, magnitude 9.1. Is about 160 feet of slip between the overriding plate on which Japan is a part and the underlying subducting Pacific plate. And it produced a devastating tsunami that reached heights of 133 feet above sea level, traveled inland as far as 6 miles. All right, here's some photos. Is that tsunami's just breaching, just coming over the seawall that was built to defend against tsunamis, but it wasn't built for tsunami of this size. And so this is a little later. You can see where the seawall is, how the water is now encroaching and basically destroying everything in its path. Only a few concrete reinforced steel concrete buildings were able to survive. Most of the others were just washed away. And this shows some of the devastation that tsunami left behind. And more damage, something like 16,000 confirmed dead, another 2,500 people missing, presumed dead, 130,000 buildings totally destroyed there. How are tsunamis produced today? They're generated in subduction zones where most of the time the overriding plate is locked against the seeking subducting plate along the fault separating the two plates. When the fault unlocks, the overriding plate springs back to its unstressed state. The resulting slip between plates can produce a significant uplift of the sea bottom, which can generate a tsunami. So here we see the subducting plate. Normally it's locked against the overriding plate. And when the stress reaches a critical point, that the plates come unlocked, there's rapid slip, the overriding plate returns to its unstressed state. It's again shown in these pictures here, the sequence A through E. So here we in A have just initial locking, B, the deformation of the overriding plate, increased stress, C, stress reaches its limit and the plates become unlocked and slip happens. The overriding plate returns to its original shape in D, but it causes an uplift in the sea bottom and produces a tsunami, a large swell that propagates off in both directions. Okay, so then I over the last 10 years, I've developed a code I've named Mabul for the Hebrew word for flood. It's based on a code I developed in the early 90s at Los Alamos for solving the shallow water equations on the surface of a rotating sphere. It uses the shallow water approximation, so we're able to treat the water as a single vertical layer, but with variable bottom height. The model assumes that dominant means of sediment transport was by turbulent, rapidly flowing water. And so I use what's called the theory of open channel turbulent flow to to model that sediment transport. That's the computational grid, same one I use for Terra. I assume cavitation is the dominant process responsible for erosion, degradation of bedrock, and then as a mechanism for maintaining the water velocities, I have repetitive giant tsunamis generated by rapid plate tectonics that provides that forcing. So I want to just briefly show a movie over 50 days. This is water height over the continent, and red is, of course, high magnitude, showing these tsunamis that slam into the edge of the continent and carry the sediment that's been eroded from the continent edge far inland. So that's a very dynamic process, and it is powerful for erosion and transport and deposition of sediment. Okay, for lack of time, I'm not going to re-show that. Or I guess I did. Okay, let it go again. Evidently, it's in a loop, so I've got to, I guess, move to the next. Oh, okay. So this example of the calculation, I have moving plates in the model, and toward the end, this figure on the left shows the cumulative amount of sediment that is deposited on the continents. There's about something on the order of 1,300 feet, no, 1,300 meters, about 4,000 feet on average of sediment on the continents. But it's not uniformly distributed. It's thick, large thicknesses where it's red here. And this map on the right is the actual sediment cover today. And I'm not going to go into detail, but the correspondence is striking. You notice Africa, for example, has sediment across its northern edge, and that's what we see in the model. India has hardly any sediment in both cases. There's a shield, a brown shield with no sediment, most of India. And again, North America, these gray regions are tectonic belts, and in most cases, there's lots of sediment there, so it doesn't show up so well. Anyway, it's encouraging that this model is giving, as crude as it still is, a pattern of sedimentation that has a reasonable resemblance to the distribution of sediment on Earth today. So again, we saw one of these strongholds. We saw that God has raised up people to work on pulling down these strongholds, which is exciting. So let me just close with a comment of why this issue of the flood and a solid defense of its reality is so important today. Well, first of all, the truthfulness of the Bible depends on it. The truthfulness and authenticity of Jesus depend upon it, and the relevance of the gospel depends upon it. And so I believe the reason we're seeing the collapse of our culture is the erosion of the authority of the Bible in the minds of most people. And so we're very much in a truth war, a battle for a spiritual battle. And so the defense of the flood, I believe, is plays an important part. If we're going to, if there's going to be a restoration, if there's going to be revival, restoration of awareness of the authority of the Bible, it's almost certainly going to involve dealing with these strongholds and tearing them down. Jesus clearly attests to the reality of the flood. Matthew 24, he says, "For the coming of the Son of Man will be just like the days of Noah. Whereas in those days before the flood, they were eating and drinking, marrying and giving in marriage until the day that Noah entered the ark, and they did not understand until the flood came and took them all away. So will the coming of the Son of Man be." And I suspect most of you, like myself, has the view that this time of Jesus' return is likely very soon. It could well be in our lifetimes. It could well be in the next decade or the next few years. So I encourage all of us, to add a strong defense of the flood to your apologetics toolkit. So thank you for your interest, and hopefully this was an encouragement to you tonight. Thank you. So I'm open to taking questions if anybody has any questions.
That was really good. Thank you. I have two questions. One, do you believe there were underwater or underground water that came up, like the fountains of the deep that's mentioned? And then the second one is, what are your thoughts on the hydroplate theory that's put forth by Walt Brown?
Okay, good questions. They're related questions. I would say that the popular scientific press has talked about oceans worth of water inside the mantle, and a lot of the popular versions of these reports give the impression to the average person that this water is in liquid form, when in actuality it's part of the crystal lattices of the mantle minerals. And it's definitely not in liquid form. And about the only way that water can be released at the Earth's surface is for the rock to melt. And so, and even though there was quite a bit of melting of rock, quite a bit of basalt produced during the flood, that's not enough to supply any significant amount of new water to the Earth's surface. So that's sort of a first step in saying that from the physics that I know, there's almost no way that you have chambers of liquid water beneath the Earth's surface inside the Earth. That water is gravitationally unstable and will find its way out very easily. Melted rock magma finds its way out very easily, and it's much denser than water. So, and the buoyancy force is much less than the buoyancy of the water would have. So there's no way to keep that water from breaking out if it initially were in some kind of internal chamber. So that's a fatal problem for the hydroplate theory. Dr. Brown has not addressed that issue. He fails to address it. When I raised it back in 1992, he decided to cut off the written debate. He had no answer for it. And so, moreover, there are other huge fatal problems to the hydroplate idea. Basically, it starts with a uniform distribution of granitic continental crust over the Earth's surface as a starting condition, and it has to end up with the distribution of continental crust we have today, with the present-day continents covered with a layer about 35 kilometers thick. And if you start with a layer 10 kilometers thick, basically you have to somehow take that initial layer and have it stack up like pancakes on top of the continents. And Walt Brown has no mechanism to do that. It's just absurd. So Walt Brown's good at telling stories, and for people that don't have a good science background, these stories can sound plausible. But if a real scientist, if you have a real scientist look at it, he's simply telling stories. It's not science at all. So I'm sad to report that. And my attitude. I did participate in 2 written debates with Walt Brown, one in 1992 and another one around 2010, and he withdrew from both of them. The second one was moderated, had I think 5 or 6 different flood models involved. His was one of them, and had a panel of 10 reviewers that would ask all the participants questions at which they had to provide written answers to. And again, Walt Brown simply could not deal with that, and he withdrew. And so it shows that he can't defend his model as genuine science. Any other questions?
Is there someone we can find that debate online?
I have a question. This is.
Let me answer that. I heard a follow up. Let me answer that one first.
Okay.
There is that written debate. I think it's 1,600 pages long. Was online. I think it's still online. I've got much of my participation. It posted on my website, globalflood.org, under the heading of 101 questions and answers on catastrophic plate tectonics. So almost all of those questions were taken from that debate and my answers to the questions. So I just turned my answers into a little article, which I posted on my website. So you can get a little flavor of some of the questions. And at least the questions that pertain to me. Okay, now, Heinz, you had a question.
Yeah, which begs the question is, what kind of support does this model, your model here, have in the, some of the leading creationist groups like, of course, AIG and CMI, ICR, they all have some geologists here. Have they, where does their comments?
I would say answers in Genesis. Andrew Snelling wrote a book, Earth's Catastrophic Past, and he and a centerpiece of that book is catastrophic plate tectonics.
Okay.
So he very much. And he was part of the original author list on that 1994 paper entitled Catastrophic Plate Tectonics.
Okay.
As was Steve Austin and Russ Humphreys and who else?
Michael Ord, is he okay with that as well?
No, Michael Ord has been a detractor of the idea. He was constantly in the Journal of Creation, also in the Creation Research Society Quarterly, attacking the model through the 1990s and up until about, I'd say 2015. I finally just started responding and writing some responses in the Journal of Creation. Basically the editor, I don't know whether he was trying to get more articles published or what, but it persisted in publishing what I considered just junk articles against catastrophic plate tectonics.
Hmm.
And I said enough is enough. That, you know, there's got to be some kind of reasonable peer review process to filter out these articles that have no science behind them at all.
Does he have an alternate theory? Michael
Ord, I think, has come around. I don't think he is admitting it, but he has ceased the attacks on catastrophic plate tectonics for about 5 years.
Yeah.
So you know, he was talking about, at one point he was invoking impacts, basically impacts to produce all of the geologic change associated with the flood.
Wow.
Which is just, just hard to even imagine such a thing.
Yeah. Yeah.
Okay, so at Answers, I'm sorry, at ICR, Tim Clary is very much on board, strong advocate of catastrophic plate tectonics, I would say. And Jake Hebert, I say more or less ICR is
right.
They're enthusiastic supporters. AIG they're enthusiastic supporters. CMI, Jonathan Safardi. So Jonathan Safardi has been supporting it in his books, the Answer book.
Yeah, so I assume Tess Walker is on board as well with that.
Well, I'm not sure where he was. When I would ask him questions back in the from 2000 till 2015, he was evasive. He would not answer me. And he, but I think he didn't want to alienate Michael Ord, so he published Michael Ord's prolific papers. You know, most of them weren't, directly had nothing to do with catastrophic plate tectonics. Perhaps he didn't want to lose Mike, alienate him, and I'm not sure what was going on.
Yeah.
But at one point I said, I will no longer write articles for you. I'll no longer review any articles if you're going to persist in this kind of editorial policy that you have.
Yeah.
And so I'm, that was, I don't know if that was wise, but I said enough is enough. We have to have some kind of discipline in our community.
Yeah.
We need to have some reasonable peer review.
Yeah. Well, follow up on that. What do you see as the biggest challenge you have in the theory yet?
Well,
I'm thinking of Noah on the Ark and all this turbulence occurring in the water and all in 1 year.
Yeah, he presumably built the Ark on land somewhere.
Right.
And my view is that the Ark had to quickly get out to deeper water, had to get into an oceanic where the amplitude of the tsunamis was modest.
Yeah.
Because you have these tsunamis coming on land, they're extremely destructive.
Oh, yeah.
So, but I don't have a good answer other than Genesis 8:1, the cryptic phrase, but God remembered Noah.
Right. Yeah. Yeah.
Not so cryptic.
Yeah. Okay. Thank you.
I have a question, Dr. Baumgardner. They're kind of related. The first one is, could you expand a little bit on how you're able to determine that the basalt at the ridges is relatively new? Could you expand a little bit on that? And then my next question is, are they finding a lot of fossils where those ridges are? I'm talking about in the ocean.
No, there are no fossils there. you have basically sediment, fossil bearing sediment that covers this this basement, basaltic basement rock. But that, you know, these mid-ocean ridges, most of them are pretty far from land, from continent. And so you don't have much sedimentation near the ridges. And therefore there are no fossils to speak of. And so so most of the fossils in the ocean are actually in continental shelf sediments. There are a few fossils in the sediments just off the continental shelves, but
could you expand how you're able to determine that the basalt was relatively newly formed?
Okay, there are numbers of lines of evidence, and just picking up on where I just was left off there, the sediment that it actually is on the basaltic ocean floor, that sediment usually has microfossils in it. And so there was this ocean drilling program. Last I heard, they had drilled 2,000 holes. It's probably up to at least 2,500 now. So they take, mostly they're drilling in the sediments. It's not easy to drill into the basalt. There have been a couple of holes drilled pretty deep into the basalt, but they're mostly interested in what's in the sediment. And so they're able to analyze these sediment cores from the seafloor. And there's several things in those cores that help establish the age. One, there are fossils that you can correlate with fossils on the continental shelves. So there is a sequence of microfossils, and it appears that that sequence is unique. The organisms change fairly quickly, and so they can correlate the sediment sequence in the deep ocean with the sediment sequences on the continental shelves to some degree. Also, these sediments on the deep ocean floor contain magnetic minerals, tiny little crystals of magnetite, for example. And these magnetite crystals, it turns out, are oriented. When they settle down, they end up oriented with the magnetic field when that sediment was basically deposited. And so they can track the polarity of the magnetic field in these sediment cores and match those polarities with the polarity and polarity reversals that you see in lava flows on mountains on the continents. And so there is this record of magnetic reversals that are, to be sure, they're in the basalt on the ocean bottom, but they're also in the sediments. These magnetic reversals are recorded in the sediments, and they're also recorded on land in successive lava flows. And so all these things have been studied, and so there is a magnetic record, and you can correlate. So you can correlate. So you can come up with a relative age for the seafloor just from these magnetic reversals. In addition, you can do radioisotope dating on the basalt. It's a volcanic rock, and when that rock crystallizes, some minerals provide a good record of the of the amount of decay that has occurred since those rocks crystallized. So you can apply radioisotope dating. That's probably the most straightforward way to date those rocks. I know that many creationists, dismiss radioisotope dating entirely, but I wrote an article in the Creation Research Society the Journal of Creation. I can't remember when that was, probably about 10 years ago, making the point that there is no reason that you can't use radioisotope dating with care to get relative dates that the radioactive decay is cumulative, and there's no reason to think that it varies from one point on the Earth to another. And so the main point is that our rate team showed that nuclear decay rates have been much higher in the past, so you can't use radioisotopes as absolute, to get an absolute chronology, but they do appear to be able to give, in many cases, an accurate relative chronology. So, so you've got multiple ways to get at the age, especially the relative age of the basaltic seafloor. The most straightforward one is to use radioisotope dating, but you can also use the magnetic reversal record, and you can also use the fossils, the microfossils. So there are multiple ways, and you have multiple. You can cross-check these methods against one another, and they generally agree. I would say I don't see any reason to say they don't agree. So I don't know what Keith thinks, but I suspect he agrees with all of this.
Well, isn't one of the biggest things, John, the fact that the sediments on the ocean seafloor are rather shallow, and that indicates young age for the seafloors?
Yes, that in general, we don't see much sediment. That implies a young age, but all these other indicators indicate a young age as well.
Yeah. Oh, yeah. I'm not disagreeing with that at all. The other thing too is, I don't know if you've ever done this. It struck me many years ago. We went up to the redwood forests up along the coast of Washington. There, they have some of these redwood forests, and it struck me walking around the forest. I'd never noticed before. Those forests are young. There isn't a lot of debris on the floor of the forests. There's not 10,000 years worth of stuff that's decayed and made thick. You got granite stuff all over in the mountains, and there's pine needles and stuff, but you're looking at maybe feet worth of soil and sediments of stuff that is decayed, and not 100 feet or anything like that, or thousands of feet of forest decay. You know what I mean? And it's just not there.
One thing where, when I travel to a new area where I've never been before, that's one thing I look for. What is what age does the surface seem to imply?
Yeah. I mean, I'm walking around the forest there, and it just strikes me how young they appear, when you're just walking around.
So everywhere, I'd say there's few places on Earth where if you look at the rocks and the tree and the vegetation, is there any appearance of vast age?
I know. Well, part of the problem is people are all stuck and covered up by asphalt and everything, and they're not out in the creation anymore. And so they're easily fooled because they don't even know what's out there, half of them.
Sadly, that's true.
It is true. It really is true. Yeah, I'm looking at your thing. I pulled it up on my other computer, this Journal of Creation, 2012, volume 26.3. Do radioisotope methods yield trustworthy relative ages for the Earth's rocks? That's the article you're writing.
I
remember reading that one a while back. Yeah. Can I ask a question, John? It's somewhat related, but I wish you'd talked about some of your more recent activities. What have you been doing? You've been quiet over there since I found out you moved to the whatchamacallit? What do they call that place? Liberty University? Is that it?
Yes,
Yeah.
yes.
I remember driving through there once on the way back to Washington, D.C., kind of surprised how it was all nestled in this hot, humid little area. I don't even remember the city, what it was in. But yeah, I mean, what are you doing now? Are you doing anything more? I had heard rumors you were doing something on trying to do something on your own on the rate thing, on some of that.
Yeah, we're trying to restart 2 of the rate projects. I've just recently got, let's see how many. I think it's 21 diamonds,
Mhm.
diamond samples to check for C14.
Okay.
And then I've got, let's see how many. 3 more. Is it 3? I've got some more. I think 3 more. 3 more.
Core samples.
Zircon samples to check to measure the helium diffusion.
Are these from the Fenton Hill borehole?
No,
These are
we're
some
wanting to
others.
find other sites around the world,
Okay.
and so I guess we just. I think I'm trying to. You're right here in my office. Anyway, we're looking for a lab that will do these measurements.
That's going to be hard. You know, I worked with Ken Farley, and wrote some papers with him, about 2 or 3 papers in various places on the various things. And it turns out zircon is not a good thing to look at. The better things for thermal chronology, better understood, are apatites.
Yes,
the apatites are better to look at for thermal chronology. It's much better understood. The diffusion is really problematic. The defect diffusion is really problematic in the from the damage if things are not carefully characterized.
That's why it's taken us so long
Yes.
to get usable samples.
Yeah. Zircons are not a good thing to look at to try and characterize anything. They don't even use them much for thermal chronology anymore, just because the radioactive damage causes so much. It's counterintuitive the way the damage works. There's all kinds of extra stuff. I mean, I studied this for years, literally, and we pretty much gave up. And Farley and all have pretty much given up on zircons as being any kind of reliable source of helium diffusion at all. It's just not. It's just not, because of the damage problems screwing up all the diffusion by orders of magnitude. Orders and orders of magnitude.
So
there's traps that happen in the zircons when you get a lot of damage, but then it goes the other way when you get too much damage. So it's a non-monotonic kind of damage thing. It's counterintuitive. And unless you are able to carefully characterize the damage, and again, when you heat it up, you anneal the damage and cause all kinds of different diffusion. It's not a well-defined system. It's a very poor system to try and make any kind of conclusions out about whether it's young or old.
I think we're pretty well aware of all of this.
Okay,
and so
good.
we have worked hard to find, basically, if you're going to try to get zircons from older rocks, you've got to have a very low uranium content.
Yes.
So that the amount of damage is small.
Yeah.
Relatively small.
Yeah.
So it turned out that I think it's just God's grace that the ones we had at Los Alamos out of Fenton Hill just happened to be suitable to be.
I would argue they weren't. I would argue they had way too much damage in them. Way too much ppm of uranium-238.
I have overlaying those plots over some plots in the literature, and ours fall right where they should, and there's low enough uranium for those measurements to have validity.
No, no, John, no. I studied it for years and published on it. There's not, and you didn't have enough samples and not enough data. That was the problem. Not enough. I talked to Ken. Ken made the measurements. I know all about them. I know everything there is to know about those. I know more than you guys know about them. I have the reports from Ken directly, who made the measurements. And trust me, they're not reliable. There's retention in those things way beyond what should have happened because of the traps. Okay,
Also,
even when you
guys-
melt them, the stuff
also,
still stays,
guys-
the helium
Well,
is
first of
retained.
all, we don't melt them. We don't heat them.
No, I know what Ken did though. He did take them to melting and released a bunch of helium that wasn't supposed to be there. It should have been all diffused away, but it was trapped because there's deep traps in the thing when you damage it. There's deep helium traps. Helium can make extremely tight bound states, contrary to what Russ thought. That's all wrong. Everything he wrote was pretty much wrong. Pretty much wrong. He knew
Well-
nothing about the diffusion of helium in zircons. Zero.
Well, I
And
agree that a lot of new understanding has
Oh
come.
yeah. Oh yeah. Oh yeah. 20 years. That's why they don't do them anymore. They don't. The thermal chronology people do not rely on zircons anymore. It's been discredited because it's too complex of a system, and you have to make too many measurements of too many parameters. Those zircons were not well characterized. You guys might have thought they were. They didn't have Raman spectrum. They didn't have anything to determine the degree of damage on them. All kinds of stuff. I mean, there's so many things you have to do now. People do, these detailed not thermal imaging maps. There's maps that you can do of the diffusion density with different kinds of techniques, and they didn't have any of that. The profiles and stuff are just, I mean, I developed models for them to have various kinds of profiles, initial prehistory. And Farley now uses that so that they don't use the initial square profile because there's prehistory and pre-diffusion. And so that rounds everything, and then that makes the release lower. All those things, no, none of that data was any good. I don't care what you try and overlay.
Yeah,
The data was terrible.
I was working with a guy at the University of Göttingen in Germany.
Yeah.
And he had all these, a lot of good equipment, and we basically eliminated, I can't remember, 5 different or more, 5 or 6 candidates, very easily. But there was one that survived, and so I have those samples.
Well, no, I mean, new samples, fine, new characterization, fine, but none of it will hold up if you guys don't spend a lot of money characterizing those samples or get somebody to do it for free, because characterization and all that is everything, and the pedigree of the samples is everything, and their history. The curation of those samples is really important. The problem with the apatites, of course, is they're much lower temperature system. The so-called closure temperature is much lower than it is for zircons. Now I'm trying to remember there's one system that does quantitative retention over geologic time. And I'm trying to remember what it is, where it's really tightly bound. It'll come to garnets.
There's titanite.
No,
there's
garnets. Garnets are about the only thing that hold helium forever, basically. They just bottle it up, and they won't let anything escape. Pretty much, they're so tight when it's there. But yeah, I mean, this is really fraught with difficulties because you're going to have damage if you had accelerated decay and any amount of uranium, present. You're gonna have lots of damage, and the damage is problematic because the damage causes heating, and the heating does the annealing of the damage. So you don't even know what damage you had that caused traps. And the rate of heating is just tremendously too high for any kind of concentration because it melts the rocks and gets rid of the helium. If the rates that were purported to be the millionfold or 100 millionfold, whatever you want, those kind of numbers, they couldn't survive.
That's certainly true. We do not find evidence of that kind of heating. So
right.
That the other side of the coin of the accelerated decay had to be accelerated removal of heat. So
I know, but Humphrey's mechanism doesn't work. That's fantasy. The gravitational stuff is all fantasy because you can't deform space-time like that and not have other things happen. Okay.
Well,
that's just fantasy. His cooling method.
Yeah, I'm not counting on his. I'm not convinced about his cooling method. I'm not counting on that. I'm just saying that the evidence is that these these rocks and these minerals were not heated.
Well, yeah, I know, but maybe that means they didn't have radio accelerated decay.
That's
Maybe
right.
that didn't happen.
That's
Well, real quick, do we have any other questions? Anybody?
Crickets.
Well, I think we have people want to go to church in the morning, and you're especially so far away, Johnny. I'm afraid you're going to have a hard time getting up and going to church. So I think we probably ought to close. Thank you very, very much. And thank you, Keith. And thank you, Heinz. And thank you for all the people that asked questions. And Lord bless you.
okay. Enjoyed it. I'll look forward to next time.
Thanks, John.
Keep up the good work,
Great.
John. Glad you're still active. It's great to hear from you.
Yeah. Good to see you again.
Okay, take care.
Okay. I'm going to sign off, get to bed.
Good night.
Okay. Bye-bye.